Now, I invite our speaker, Dr. T. Vinay Kumar Garu, onto the dais. Thank you, sir. Now, I ask my colleague, Mr. Prasad, to brief out the biodata of today's speaker, Dr. T. Vinay Kumar Garu.
Respected dignitaries and good morning all of you. It's my privilege to behalf about today eminent speaker Dr. T. Vinay Kumar Garu. Sir completed his PhD from NIT Warangal, research fellowship in University of New South Wales, Australia. Present working as assistant professor in electrical engineering department in NIT Warangal. Sir taught various subjects at both UG and PG level. He published research publications total of 33 in IEEE transaction, IIT and Francis. He attended and presented in 12 conferences both at national and international level. He is having 3 research and development projects sponsored by SERB and guided research scholars. 5 are awarded with PhD and 1 is ready to submit. Thank you.
Thank you, Mr. Prasad. So with this, I invite our resource person and today's speaker, Dr. T. Vinay Kumar Garu, to start his session. Thank you.
Yeah, good morning to all. Yeah, myself, Dr. T. Vinay Kumar, Assistant Professor, Department of Electrical Engineering from NIT, Warangal. So, in today's session, I would like to introduce the topic. First, we'll try to discuss fundamentals of electric drive. After that, we'll try to discuss in detail about what is the difference between classical speed control methods and advanced speed control methods. What are the methods they are adopting in EV application? We'll try to discuss in today's session. So, what is the object of today's session? What is main objective? We'll try to discuss control the speed of the various electrical machine. Now, question is, see, if you want control the speed, what is the main cost component? How we can control the speed of speed of the shaft or position of the shaft practically? See, if you take any motor, what is the expected output of the motor? If you take any electrical motor, whether it is a DC motor or AC motor, whether it is a single phase or multi-phase machine, what is the expected output of the motor? Output of the motor, simple. What is the input to the, what we are applying to the motor? We are applying voltage. Am I correct or not? See, why we need to apply voltage across the motor terminal? See, in first, see, so today's session I am having three. Today I got three sessions. Three break is there, Sunil? Otherwise, morning and so I got two sessions, morning and afternoon sessions, right? So, if possible, morning session I will try to discuss completely fundamentals of electric drive. Why? Because most of the participants are from undergraduate students only. I don't want to explain in detail about the advanced methods. First, I will try to highlight the fundamentals of electrical machines. Okay, so what type of machines they are adopting in electric vehicle application, we'll try to discuss. I will try to explain in detail. After that, what are the methods they are adopting in EV application to control the speed instantaneously, right? So, question is, why we need to apply voltage across the motor terminal? What is the function of voltage in electrical circuit? See, before discussing what is the nature of voltage, what is the nature of torque, what is the nature of speed, what is the nature of current, I want to tell one important point. You heard about Newton's law, Newton's first law. What is Newton's first law? What is Newton's first law? See, if you want change the state of the object, any object, it required force. It required external force. Without external force, we cannot change the state of the actual system, whether it is a mechanical system or electrical system or hydraulic, any system. Here, if you want change the state of particular system, state of the object, it required external force. Clear? By using external force, we can do job. Particularly in case of electrical circuit, by using voltage, we can do job in electrical circuit. Without voltage is nothing but electrical force. By using voltage, we can pull or push the electrons based on the requirement. The magnitude of the current is directly proportional to applied voltage. So, with respect to electrical circuit, what is the nature of current? Current is always depends on the voltage. That's why in case of electrical circuit where voltage is called forced component, it is a main cost component to do job in electrical circuit. Am I correct or not? Clear? So, if you want to do any job in electrical circuit side, it required voltage. Voltage is the main cost component to do electrical job. Right? Now come to mechanical system. In case of mechanical system, if you want change the shaft speed or if you want change the position of the shaft of the motor, it requires torque. You know torque, what is torque? It is force only, twisting force. Right? Clear? In case of electrical circuit, voltage is force. By using voltage, we can we can accelerate or we can deaccelerate the current. In case of mechanical system, by using torque, we can accelerate or deaccelerate the shaft speed. Right? Now, thing is, what is the other name of voltage? There is a generic name is there for voltage or torque. What is the name of voltage or current? These components are called main cause component. Voltage is called main cause component in electrical circuit. Torque is called main cause component in mechanical circuit. But issue is, problem is, we cannot convert electrical to mechanical or mechanical to electrical simply like that. What is the reason? What is the problem with electromechanical system? If you take any machine, DC motor or AC motor, single phase or three phase, there is a air gap is there between stator to rotor. If there is any air gap, how we can transfer the energy? Through magnetic circuit. You need to adopt magnetic circuit. So magnetic circuit is acting as a mediator between electrical to mechanical or mechanical to electrical. Now question is, what is the advantage of magnetic circuit? What is the use of magnetic circuit? Advantage later I will explain in detail. What is the function of magnetic circuit in electromechanical system? What is the use of air gap? What is the function of air gap? See, whatever electrical energy you are applying to the stator, total energy will transfer into air gap. Energy will store in the form of magnetic circuit, magnetic field, that is called field energy. Right? Later, this field energy will transfer to rotor. Clear? So, whatever energy is available in air gap, that energy later your rotor will extract. How it will extract? In detail, what is the nature of torque developed by the DC motor? What is the nature of torque developed by the induction motor? What is the nature of torque developed by the synchronous motor? First, I will try to explain in first 1 hour. After that, I will try to explain the advanced speed control methods, particularly in EV application. I will try to explain. Right? So, in today we'll try to discuss, these are all the topics we'll try to discuss in detail. First, we'll try to put more concentration on fundamentals, right? Without knowing the fundamentals, very difficult to understand this concept. This is advanced. Last three methods are advanced speed control methods. Most of the satellite application, aerospace application, submarine application, electric vehicle application, they are adopting these methods. Last three methods: field orientation method, direct torque control method, predictive control method. Right? So, question is, before understanding the advanced speed control methods, if you want to control any system, what it required exactly? Now I want to control this. I don't want to control the students. My aim is I want to transfer the energy to the students. Right? If you want convert electrical to mechanical or mechanical to electrical, here you have to transfer the energy effectively. See, if I want to transfer the energy from if I want to transfer the energy from faculty to the student, first what is the requirement? What is the first step? Before controlling the students, I want to control the system. If you want to control the system, what information is required? Anyone? See, we cannot control simply like that, right? If you want to control any system, first step is you should know actual system characteristics. You should know actual system behavior. You should know what is the level of understanding of the students. You should know what is the initial knowledge of the students. Each and everything you should know. If you know the initial characteristics, or if you know the transient response of the particular system, how system is behaving in transient condition, how system is behaving in steady state condition, if you know without applying any force, right? If you know the natural characteristics of the system, we can easily control. Without knowing the characteristics of the particular system, we cannot control. Now question is, so what is our topic today? What is our topic? Our topic is motor control. Our aim is control the speed of the motor. Clear? So first we will try to discuss what is the nature of motor characteristics. DC motor, induction motors, synchronous motors, right? Next, salient pole synchronous motor, cylindrical pole synchronous motors. Nature will try to discuss in detail. Now I want to ask one important question here. See, if you take DC motor or AC motors, there is a commonality is there. What is the commonality among the all electrical motors? Hmm? There is a commonality. See, the way of generating torque is different in DC motor and AC motors. But basic principle, torque generated principle is common for DC motor as well as AC motors. Now my question is, if see here electrical machine, we based on the requirement, same machine we can operate in generating mode as well as motoring mode. Clear? Now, whenever you want to operate the generator, whenever you want to operate electrical machine in motoring mode, right? So your job is you need to take care about input voltage, magnitude you need to take care. Whenever you want to operate the machine in motoring mode, you need to take care about voltage. Whenever you want to operate machine in generating mode, you need to take care about torque, prime mover torque, you need to take care. So finally, what is the expected output of the generator? Any generator. What is the output of the generator? Voltage. Voltage is the output. Please start understand. Don't say electrical energy. Electrical energy will transfer after connecting the load. Please start understand. Energy will transfer over the period, right, after connecting the load. Otherwise, initially, if you take any generator, expected output of the generator is voltage. What is the expected output of the motor? Torque. These two you have to remember throughout this session. Why? Because these two components, how these two components are correlated, particularly in electrical machine, we'll try to discuss in first session, fundamental session. Voltage is the output of the generator, torque is the output of the motor. Next question is, here even if you want to generate the voltage or even if you want to generate the torque, here you need to satisfy one important condition. What is the condition? Necessary condition you need to satisfy if you want to generate the voltage using DC generators or AC generators. There is an essential condition is there. What is the essential condition? How we can generate the voltage? If you want to generate the voltage, what is the necessary condition? You need to take care. Why prime mover is required? If it is operating, your machine is operating in generating mode, why prime mover is required? Prime mover will provide the relative motion. Prime mover will provide the relative motion between the conductor and flux. Clear? If flux is constant, if conductor is alternating, then what you will get according to Faraday's law, you will get EMF. Or conductor is fixed, position is fixed, but flux is alternating, also you will get EMF. Right? So final, what is the conclusion? If you want to generate the voltage, necessary condition is you need to provide finite relative motion between the conductor and flux. Right? This is very important, right? Whether it is a DC generator or AC generator, if you want to generate the voltage, you need to provide finite relative motion between the conductor and flux. Clear? Finite relative motion is required in case of generating mode. Now come to motoring mode. See, if you want to generate the torque, what is the essential condition? Whether it is a DC motor or AC motor, what is the essential condition? You need to take care, you need to satisfy, then only you will get twisting force, then only you will get torque. What is the essential condition we need to satisfy? Anyone, at least one student. See, in generating mode, relative motion is required between conductor and flux. In case of motoring mode, what is the essential condition? In case of motoring mode, right, throughout the operation, you need to maintain zero relative motion between the stator flux and rotor flux. Zero relative motion is required. What is meant by zero relative motion? What is the speed of the participants? All are stationary. Speed of the participants is zero. What is the speed of lecture? Zero. What is the relative motion between the student and faculty? Zero. That's why we are able to interact. That's why we are able to interact. That's why we are able to understand the concept. Otherwise, if students are stationary, faculty is running with 1000 RPM, right? Very difficult to understand. Or faculty is stationary, students are running, we cannot, right? Torque is mainly because of interaction between the stator flux and rotor flux. In order to interact, see, when these two flux will interact to each other, relative motion is 0, then only both will interact. Students and faculty, if both are the relative motion between the student and faculty is 0, right? If student is running 1000 RPM, faculty is also running 1000 RPM, no issue. Students can understand the concept. Understood? You got my point? If student is running with 1000 RPM, faculty is also running with same speed, no issue. Nothing will happen. But if students are stationary, faculty is running, or faculty is stationary, or students are stationary, faculty is running, very difficult to interact. Interaction is required in any electrical motor. Right? So, for understanding purpose, take DC motor. In case of DC motor, poles are excited with field current. You have studied DC motor principle? You have studied, operating principle of DC motor? In case of DC motor, what is the nature of stator flux? Stator flux is always passing from north pole to south pole. It is a fixed. It will not vary. Speed of the stator flux is 0. Similarly, what is the position? Here, what is the nature of rotor flux? Rotor flux always in phase with brush axis. Clear? So, brushes are stationary. If brushes are stationary, rotor flux is also stationary. With respect to each other, what is the relative motion between the stator flux and rotor flux? What is the relative motion? 0. That's why these two fluxes are interacting to each other. Finally, you will get twisting force. If you want to generate the torque, essential thing is you need to maintain 0 relative motion between the stator flux and rotor flux. This is very, very important. Why synchronous motors are not self-starting? What is the reason? Why synchronous machines are not self-starting machines? Anyone? Relative motion is finite. There is a finite relative motion is there between stator flux and rotor flux. Because of this reason, there is no twisting force in the synchronous machine here if NR equal to 0. There is no torque. Reason is rotor poles are stationary, stator poles are rotating with 1500 RPM. Relative motion between the stator pole and rotor pole is NS. So because of this reason, here there is no interaction between the stator pole and rotor pole. There is no attraction or repulsion force between these two. That's why you will not get any twisting force in case of synchronous machine. What is the advantage of asynchronous machine? Induction machine. Induction motor is self-starting or not self-starting? It is a self-starting. Reason is, irrespective of the operating speed, whether operating speed is 0 or speed of the rotor is 1000 RPM or 1500 RPM or above 1500 RPM. Here, irrespective of the operating speed, if you verify the relative motion between stator flux and rotor flux, it is always 0. Speed difference between the stator flux and rotor flux is 0. Because of this reason, here even operating speed is 0, your machine will generate finite torque. Clear? How many third year students are there? Raise your hands. Third year. Any fourth year students are there? Fourth year? No. Second year? Second year students? Okay. Second year students, you have studied DC machines? Yeah. Completed? Okay. Now, question is, see, first we will try to discuss motivation. Before discussing operating principle, fundamentals of various electrical machine, first step is why motor is required in electric vehicle. That is important, right? Motivation is very, very important. Why you are entering in electrical engineering? What is the reason? See, you have to enter, you have to do some work with motivation, intention, goal, you have to enter. Right? So, here already see most of the cases they are adopting IC engines. Most of the conventional vehicles are operated with IC engines. Nowadays, most of the IC engines are replaced with electric vehicle. What is the advantage of EV here? See, these are all the various parameters. By using various parameters, we can see, we can identify the merits of the EV, electric machine in vehicle application. Clear? What are the parameters? Number of moving parts, reliability, efficiency, bidirectional, energy recaptation, power density, noise, vibration. There are so many factors are there. See, there are so many factors are there, but thing is, this is a very important point. This parameter, you cannot find in the IC engine. What is meant by bidirectional power? What is bidirectional? Power is flowing source to machine or machines to source. Clear? See, in case of IC engine, you cannot operate IC engine in generating mode. You cannot extract the power from the IC engine. Simply IC engine will it will give mechanical power to the vehicle, right? But it will not operate in generating mode. That is the problem with IC engine. But if you adopt electric motor in vehicle application, here whenever your machine is operating in deaccelerating mode, whenever you want to stop the vehicle, you need to apply brake, right? So whenever you want to deaccelerate the drive or whenever you want to stop the drive, see, you have to apply brake. Whenever you apply the brake, what will happen? Here your machine will enter in generating mode. Now question is what is the difference between motoring mode and generating mode? Anyone? I want to ask question so that I can understand the characteristics of the students. Based on the student characteristics, I will change the modulation of my lecture. Without knowing the student characteristics, very difficult to teach. Even if I teach, right, without energy, without observing the power, no use, right? I want to ask one question before, anyway, these points, anyway, I will explain, I will forward PPT, it is fine. I want to ask one important question. What is the significance of reactive power in electrical system? What is the function of reactive power? You heard about reactive power name? Reactive power. What is the mathematical equation? VA sine theta. Real power is sine or cos? Sine. Real power VI cos. Okay, you forget about mathematics. Very simple question. What is the nature of reactive power in electrical system? If you refer any textbook, they are mentioning that it is a wattless power, something they meant. Please start understand reactive power, what it will do exactly in all electrical system. It will create environment. Please start understand. Reactive power will create environment to do real job. You got my point? If you want to do any job, first you have to satisfy the reactive requirement. Reactive power requirement you have to satisfy. Right? So in case of electrical machine, whether it is operating in generating mode or motoring mode, first you need to supply magnetizing flux. You need to supply magnetizing current. Right? So what it means, magnetizing flux is nothing but it is creating good environment to do the job, to get the mechanical power or to get the electrical power. First step is you need to create environment. Environment should be clear. If environment is fine, we can work freely. Reactive power will create good environment in all electrical system. If there is a sufficient reactive power is there, so that we can do real work. Real work, they will calculate it based on the VI cos pi formula. Clear? Without reactive power, we cannot do anything. Please start understand. This is very, very important. Reactive power will create environment to do real job. That is, see, in case of generating mode or motoring mode, first you have to create good environment to convert the energy from electrical to mechanical or mechanical to electrical. Without reactive power, we cannot do anything. Reactive power is nothing but it is creating good environment to do work. If environment is good, there is no, here air is very good, very clean, very clear. Pollution in the air is very clear, we can work easily. If there is any pollution is there in air, we cannot do anything. Clear? So here also, next come to one more important parameter, efficiency. The main problem with IC engine is efficiency of the IC engine is less than 45%. But if you take electric motor, if IC engine is replaced with electric machine, if IC engine is replaced with electric motor in vehicle application, efficiency of the motor, even if you take induction motor, permanent magnet synchronous motor, switch reluctance motors, efficiency it is more than 90%. If efficiency is very good, right? Next, power can flow both directions, machines to source or battery to motor or motor to battery, both it is possible. Next, one more important thing is, this is a very important point, CO emission. There is no air pollution if you replace IC engine with electrical machine, right? No vibrations, no noise pollution, right? Next, one more important thing is power density is very good. Power density is very, very good for electrical machine. What is the advantage of power density? Anyone? If power density is very good, size of the machine will compact. What is the function of IC engine? What is the function of motor? Finally, even if you take IC engine or electric motor, both will produce the mechanical power to the system. Both will give mechanical power to the system. Clear? Both are mechanical energy producing device only. Even if you take electric motor or IC engine, both will generate mechanical power to the system. But thing is, while generating the power, particularly in case of IC engine, efficiency is less than 45%. Right? Next, efficiency of the electric vehicle, if you adopt electric machine, if you adopt in vehicle application, efficiency is more than 90%. One more important thing is size of the electric machine is very compact. Why we need to take care about the size? Space requirement. Particularly if you take aerospace application, satellite application, submarine application, even if you take electric vehicle application, what is the main challenging in electric vehicle application? Aerospace or submarine, satellite application, there is a limited space is available for drive machine. Am I correct or not? There is a limited space is there. With small size you need to produce, with small size you need to produce maximum power, more power, right? That's why nowadays most of the satellites, aerospace application, submarine application, they are adopting electric machine instead of IC engines, right? These are all the advantages of, there are so many advantages are there when compared with IC engine. That's why nowadays most of the industry people, they are trying to replace IC with electric machine, right? So what is the motivation? Why people are motivating? Power density is very good. Power density is good. Size of the machine is very compact, lightweight, same power it will generate with less size. Clear? So these are all the advantages of electric motor if you adopt in vehicle application. Now come to, this is complete overview of the electric vehicle propulsion system. See, there are so many parts are there in EV application. See, electric vehicle propulsion system. What are the parts? What are the main parts in EV application? Batteries, right? Next, controllers, power converters and motors, right? So what type of motors they are using in vehicle application? What type of motors they are adopting? EV application, DC motors, induction motors, permanent magnet synchronous motor, switch reluctance motor, interior permanent magnet synchronous motors, right? But thing is, nowadays no one is using DC machines in EV application. Before 1970s, before 1960s, they were adopting DC motors in EV application. Please try to understand. Nowadays, no one is adopting DC motors in vehicle application. I will explain why they are not using DC motors in EV application, why they are preferring AC motors in EV application. I will try to explain by using mathematics so that you will get clarity. There is a mathematical proof is there, right? So next, one more important thing is, in today's session, what is our main objective of today's session? We will try to understand the operating principle of various electrical machine. when it is operating in motoring mode, how it is behaving, we'll try to understand first. After that, we'll try to discuss, first we'll try to put more concentration on characteristics of the various motors. After that, see, we'll try to discuss control methods. What are the control methods? These are all the control methods, nothing but it will come under software category. It is a technique, mathematic techniques. Logic, control method is nothing but it is a logic. By using this logic, right, it is a mathematical derivation, mathematical logic. By using this logic, right, we can control the speed of the motor effectively through power converter. But power converter, we cannot, how power converter, power semiconductor element we can access, how we can control the output of the power converter. You know rectifier, how we can control the output of the rectifier? Through gate pulse, through control pulse. Control pulse will come from where? Control pulse is coming from where? Where it is coming? What is the base for deciding the duty period of the switch? Based on the requirement, based on the logic. Clear? So this logic, what they will do, all logics they will implement in controller. This is digital controllers, all are digital controllers, microprocessor. What is the purpose of microprocessor, DSP or FPGA boards in EV application? What is the function of controller? Controller will execute the logic, simple. It will execute the instructions, right? So simply after execution, what you will get, if you take any controller, the expected output of the controller is pulse. You know what is pulse? Pulse is nothing but gate signal to the semiconductor element. So finally, this software, by using this control logic, see, by these two are very important. These two are very important to improve the dynamics of the electric vehicle application, right? So this logic, if you implement by using this controller, we can execute. After execution, what you will get? You will get pulse to the power converter. On and off, we can decide it. Who will decide on and off? Your control logic will decide. So that output of the power converter we can control through duty period, so that here input to the motor. What is the input to the motor? Voltage or frequency. You got my point? Motor input is voltage or frequency. These two we can control through power semiconductor element. So by changing the voltage and frequency of the motor terminal, we can control the characteristics of the motor. What is the output characteristics of the motor? Speed and torque. Output of the motor is, if you take any motor, basically torque is the output. So because of force, you will get speed. Clear? In case of electrical circuits, whenever you apply the voltage, then only you will get current. VI characteristic is the general voltage and current. These two are main cause and effect in case of electrical system. But in case of mechanical system, torque is the main cause component to change the dynamics of the shaft, right? So finally, what is the procedure here? What is the operating, what is the sequence here? What is the first step? What is the first step? Whether your machine EV is operating in motoring mode or generating mode, who will decide? Customer will decide. You got my point? Whether vehicle is accelerating or deaccelerating, or if you want to stop the vehicle completely, it is based on the customer requirement. So customer, whenever he press the acceleration, immediately what will happen? Here, you in the software, reference speed will change. Reference speed will change. Based on the reference speed, your software will calculate how much duty we need to maintain across through the power semiconductor element. Your software and combination of software and hardware, nothing but controller will decide. So based on the duty period, your power converter will generate the voltage and frequency to the motor, so that motor will obey the instructions of the customer point of view. Simply, motor, if you take this one, motor don't have any freedom. motor characteristics will forcefully will obey the power converter characteristics. Converter characteristics are depends on the controller inputs to the semiconductor element, right? Power converter characteristics are completely depends on controller. Motor characteristics are completely depends on power converter behavior. How power converter is behaving based on the nature of the power converter, we can change the characteristics of the motor. You got my point? It is a very simple. Don't get confused. See, motor characteristics are depends on the power converter characteristics. Power converter characteristics are depends on the logic. What type of logic you are executing, whether it is a variable voltage or variable frequency or field orientation method or direct torque control method or model predictive control method, what type of method you are adopting based on the requirement, that is so important. Clear? You clear everyone? This is complete overview of the electric propulsion system. So first session we'll try to put more concentration on this topic. After that I will try to explain what are this software side. I will explain one or two methods so that you will get clarity, right? Now these are all the various applications of EV. These are all the motors there are adopting in various models, EV models. See, if you observe this one, earlier days before 1960s or before 1950s, most of the EV companies there were adopting DC motors, DC series motors, shunt motors or separately excited motor. But at present, these all are latest models. No one is using DC motors. What is the reason? I will explain in detail. See, at present, all EV companies they are adopting only AC motors. No one is using DC motors in vehicle application. What is the reason? We will try to discuss. Before that, this is very important sheet. This is called progress card. This is like progress report for the various electrical machine. So, see, in today's session, I don't want to discuss another parameter. I want to put mainly on this parameter. What it is? Controllability. Controllability. What is mean by controllability? How machine dynamics are vary based on the inputs. Clear? How machine dynamics are regulating whether controllability is good, whether student is controlled or uncontrolled, right? Control is easy or difficult, how we can decide? This one, see, DC motor, what is the nature of DC motor? Maximum marks for each category is 5. Maximum is 5. For DC motor, controllability, with respect to controllability point of view, it got 5 out of 5. 5 out of 5 is nothing but controllability of the DC motor is very, very good. Right? It is a very good control machine. Now come to this, all are AC machines. Remaining rest of the machines are all are AC machines. Right? For induction motor, controllability is only 4 out of 5. PMSM, permanent magnet brushless motor, 4 out of 5. Switch reluctance motor, 3 out of 4. 3 out of 5. Permanent magnet hybrid motor, 4. See, anyway, compared to DC motor, all other machines controllability is poor, less only. Clear? Now question is how to decide controllability factor. How we can decide whether DC motor controllability is very good, AC motor controllability is very poor. How we can decide? What is the base? Controllability of the motors will decide based on the number of variables involved in the torque expression. This is very, very important. See, if you take any motor, what is the expected output? Already we discussed. Output of the motor is torque, right? Based on the torque profile, we can decide. Based on the torque profile, we can decide whether controllability is good or controllability is complex. Control logic is simple. Each and everything we can will decide based on the torque profile of the various electrical machines. Right? Now, this one I will explain later. This portion, this part I will explain later. Now come to, I want to highlight this part first. How many students are following? Everyone is following? I don't know how many students are. Okay. Everyone is following? Fine. I will ask questions after 1 hour. After I need to ask questions. Interaction is required. Without interaction, no use, no talk. Interaction is required, right? Why? Because you are all are stationary. Students are stationary. Faculty is stationary. We are interacting. Almost half an hour is over. 40 minutes over. Later, I will ask questions. Right now, thing is, see, particularly next one more thing is particularly for electrical students. Advantage of the electrical students compared to other branches is we're having mathematical proof for all cases. Whatever topic you are taking, even if you take control system, power electronics, electrical machine, right? If you take any concept in electrical engineering, the advantage of the electrical engineering is we're having mathematical proof for all cases. What is the advantage of mathematics? If you're having mathematical support for particular concept, we can easily understand. But students are, they are not depending on the mathematics. Problem is here before entering in the triple course, they are afraid like anything. Electrical is a tough course. Electrical branch is tough course. Some students may join interest with interest. Some students may join forcefully, right? Due to parents' force, they may join. Thing is, anyway, see, once you entered in a particular system, your job is you have to identify what is the shortest path to understand the concept. For electrical engineering, shortest path is if you want to understand any concept, advantage is we are having mathematical proof is there, mathematical support is there. That's why mathematics, it is not a subject for electrical student, it is a language. Each and every concept you have to understand through mathematics. You got my point? But students, they are not depends on the mathematics. Simply, they are reading the theory. Textbooks they are taking, they are practicing the diagrams, they are practicing the theory. Even in examination also, without mathematics, they are writing 2 pages, 3 pages, red pen, blue pen, 1 HP pencil, 2 HP pencil, underline, right? They are not concentrating on mathematics. They are not concentrating on problem solving, right? If you are very strong in mathematics, we can understand the concept in detail. Once you know the concept in detail, advantage is you no need to by heart anything, right? See, now come to, now I will take one universal expression, torque expression, so that by taking single expression, mathematical expression, I will try to explain what is the nature of DC motor, what is the nature of induction motor, what is the nature of synchronous motors. I will try to explain in detail. Here there is a standard mathematical expression is there. Here that is called, it is missing here in this document, it is missing. I am looking that equation. Anyway, I will explain. Wait. Here, see, there is a standard torque expression is there, which is applicable for all electrical machine. T equal to generated torque equal to xi s xi r sin delta. You know this equation? T generated torque equal to xi s xi r sin delta. Any chalk piece or any board is there? There, chalk. Here I can write here. Oh. Understand? This is the standard expression. This is called universal torque expression, common for all electrical machine. Your job is you need to remember only this equation. If you remember this equation, we can easily understand what is the nature of torque generated by the DC motor, what is the nature of torque generated by the AC motors. Various electrical machine we can understand. What is Zs? Eraser. What is Zs? It is a stator flux. Zr is the rotor flux. Linkage. Delta is, what is delta? It is a space displacement angle between stator flux and rotor flux. This equation is applicable for all electromechanical machines. Right? This equation is applicable for all reaction torque machines. DC motors will generate reaction torque. Induction motors also will generate reaction torque. Synchronous machine, cylindrical pole machine will generate the reaction torque. Synchronous with salient pole machines will generate reaction plus reluctance torque. These two are possible. Now, here stator, rotor. This is angle between these two. Now, by using this equation, we can understand controllability of the DC motor or controllability of the AC motors are difficult or not. Even if it is a difficult, controllability of the DC motor is very, very easy, very effectively also, but industry people, they won't like DC motors. Except traction application in India, most of the industrial drives are induction motors, as well as in EV application, they are using permanent magnet synchronous motors. In foreign countries, in other countries, no one is using DC machines in application, in industrial application or traction application. Please try to understand. What is the reason behind, right? Nowadays, see, there is a lot of research is going on to replace the DC series motors with induction motors in electric traction application, even in India also. Coming next 4 or 5 years, within 4 or 5 years, here all DC series motors, they are trying to replace with induction motors using field orientation control. That is what we are going to discuss in today's session, right? So before discussing advanced control methods, first we will try to discuss fundamentals, right? Question is, why controllability of the DC motor is very good? Why it got 5 out of 5? By using this equation, we can understand. That is the advantage of electrical engineering. I am telling, if you take any topic in electrical engineering, next one more thing is, one more advantage of electrical engineering subjects are, we are having only 3 elements. If you take any subject, any electrical subject, it is deals with only 3 elements, R, L, C. But students, they are not understanding what is the nature of R, L and C in detail. That is the problem. If you know the nature of the each and everything, how current through the inductor is, what is the nature of inductor current, what is the nature of capacitor voltage, how it is behaving in transient condition, how it is behaving in steady state, right? If you know this concept in detail with mathematical support, right, you no need to by heart any subjects. Electrical, I am telling frankly, electrical subjects are very easy if you depends on mathematics. Right? See, if you by heart something after 1 hour or half an hour, you may forget everything. But if it depends on the equation, see, wherever I go, I will remember always. See, I don't want to by heart anything before going to class or before giving lecture to any audience. I will remember only equation. By taking this equation, I can manage almost 1 hour class. I can engage the class more than 1 hour, more than 2 hours also I can manage. That is the beauty of the mathematics. Mathematics, it is not a subject. It is a language. Once again I am telling, it is a language for electrical students. If you depends on mathematics, everything will clear. Gaps we can fill. Now first we will take DC machine. DC motor I will take. In case of DC motor, here take north pole, south pole. So this one, this is the nature of Zs. Zs is always in phase with brass axis, in phase with pole axis. This is the nature of Zr. Clear? So what is the angle between these two? Who will maintain this 90 degree? Who will take care? 90 is variable or constant? 90 degrees is a variable or constant? It is a constant, irrespective of the operating speed, right? Whether operating speed is 1000 or 100 or 150 or 500, irrespective of the operating speed of the rotor, here the nature of the space displacement angle between pi s and pi r is always 90 degree. Your commutator will take care. You no need to worry about anything. Your commutator, the combination of brush and commutator will maintain space displacement angle between pi s and pi r. Xi s and Xi r is 90 degree. If it is a 90 degree, what is the advantage? If it is a 90 degree, it is a constant. If delta is 90 degree, what is the advantage? This one become maximum. Sin delta become maximum. So finally, what is the torque expression? Xi s, Xi r. Now question is, what is the order of this equation? How we can decide, what is the base for deciding the controllability? Whether control is easy or difficult, how we can decide? It is based on the number of variables involved in the equation, right? Where torque is the potential element of the motor. If you take any motor, expected output is torque. This torque, here torque produced by any motor, it is a function of, torque is a function of various electrical signals, right? That's why it is called electromechanical system. So finally what is the order of this equation? Is it second order? There are two variables are there in torque expression. One is Xi s, another one is Xi r. Xi s is function of IF, field current. Xi r is function of IA. You got my point? So finally, this one, IF, this is function of IA. Where IF is current passing to the field coil, IA is current passing to the armature coil. These two are inductance only. So these two currents we cannot change instant to instant. That's why these two are called state variables. Current through the inductor is called state variable. Voltage across the capacitor called state variable. See, in case of DC motor, here if you take torque expression after commutation action, right? The nature of the torque is, it depends on the two variable. Torque is function of IA and IF. But what is the problem here? Is it linear or non-linear? Torque expression. This equation is linear or non-linear? Okay. Whether it is, what is the order of this equation? It is a second order. Torque is in second order. It is a non-linear equation. How we can decide what is the difference between linear and non-linear? Very simple. If one variable is multiplied with another variable, then it is a, one variable is multiplied with another variable, then it is called non-linear. If one variable is adding or subtracting, then it is called linear. Addition, plus, minus, these two operators are coming under linear category, addition or subtraction. Multiplication or division will come under non-linearity category. If one variable is multiplied with another variable, or one variable is divided with another variable, then automatically your equation become non-linear. Otherwise, if one variable is adding or subtracting with another variable, then your system become linear. Here problem is, here your torque is in second order. What is the problem with second order? Anyone? If torque is in non-linear, basically second order is also non-linear. Order is less. But problem is, here it is in non-linear nature. Non-linear systems control is very difficult. So here till now we discuss what is the nature of the torque without adopting any control logic. Till now we are not adopting any control logic. Simply, we are trying to extract the behavior of the machine. We are trying to extract the what is the nature of torque producing by the machine. Torque produced by the DC motors are nonlinear in nature. If you want control this equation, very difficult. Dynamic response is very poor. We cannot control the torque instantaneously. If you want change the torque from 1 Newton meter to 2 Newton or 2 to 3 Newton meter, if you want change, we cannot change instantaneously. Instantaneous control is not possible if it is in nonlinear mode. You got my point? Now, how we can convert second order to first order? How we can convert nonlinear to linear? First order nothing but linear. Anyone? How I can change the student characteristics? By teaching the concept using mathematical support. Effectively, if I teach student characteristics, I can change. From higher order to lower order, I can bring. Clear? Now, here, in case of DC motor, you heard about armature voltage control method. You heard what is the main object of armature control method? Control the speed below base speed. By adopting armature control method, we can regulate the speed below base speed. But you are not understanding what is the logic behind the armature control method, how dynamics of the machine is regulating, how system is converting from nonlinear to linear, you are not discussing. These points you won't get any textbook in textbooks. No textbooks will mention these points. Am I correct or not? So your job is you have to analyze the concept beyond the limit so that you no need to by heart anything. That is what I am trying to tell in today's session. This equation is there in all textbooks, but beyond the limit, you cannot find the points. You cannot get the conclusion in the textbooks. As a scholar, as a student, you have to analyze in detail so that you will get clarity. What will happen inside the machine? So, in armature control method, what we are doing? Forcefully, we are maintaining field current as a constant. Am I correct or not? This is the first step you have to follow in armature control method. If field current is constant, if IF is constant, then Zs is also constant. If it is a constant, what is the torque expression? K into ZR. ZR is directly proportional to IA. So what is the order of this equation? First order. First order nothing but it is in linear mode. If your torque is in linear mode, we can control the torque instantaneously. Why I am trying to tell this point? In all EV application, satellite application, robotic application, aerospace application, instantaneous torque control is requirement. Their main require is you need to control the torque instantaneously. If you are able to control the torque instantaneously, automatically we can control the speed or position of the shaft instantaneously. Torque is the main cause component to change the shaft dynamics. Right? So finally, here before adopting the control logic, basically all systems are nonlinear. Why faculty is required to the students? Students also can read. They know English very better than the faculty. They can go through the textbook, they can learn. But why faculty is required? Faculty is trying to bring this nonlinear system. They are trying to change the mental characteristics of the students. Am I correct or not? That is the purpose of faculty. Everything is there in textbook. Why faculty is required? Faculty will explain the concept effectively, in detail, with less time. Right? Clear? Without biting anything, they will try to explain the concept to the students in different ways with examples like that. Many faculty, they will explain the concept with practical examples. Right? Here also, before control method, it is in nonlinear. After adopting the control logic, system become, after adopting the armature control method, it is a mechanism, control method. By adopting mechanism, we are trying to convert from nonlinear to linear. If it is in linear, instantaneous control is possible. Now, what is the beauty of control method? What is the advantage of control logic? Practically all machines are nonlinear in nature. That is the nature of student, nature of the system also, all are in nonlinear. Nothing but basically dynamics of the students, right? Dynamics of the machines, basically without any control, all will perform with poor dynamics. Dynamic response is very poor, naturally. By using control mechanism, we can improve the dynamics. That is what we are doing in engineering practice. Right? Everyone understood here up to here? What is the, after adopting armature control method, what is the order? It is in first order. It is in linear mode. Linear equation is required. If it is linear, this one, how we can control this component? By regulating IA, we can control torque. IA, how we can control? What is the cause component? According to Newton's law, if you want to change the state of the object, it required force. What is the force? This one. Through armature voltage. By regulating the VA, we can control IA. By controlling IA, we can control torque. By controlling the torque, we can control. Very good. Finally, our aim is, with respect to customer point of view, he will see what is the operating speed of the vehicle. He will see. He is not bothering about what is the torque generated by the machine. He will not bother about what is, see whether torque is in linear mode or non-linear mode. He will not bother. His requirement is instantaneous speed control. Instantaneous position control is required in robotic application. Robotic application, satellite application, aerospace application, instantaneous position control is required. If you want to control the speed instantaneously, main thing is torque should be linear mode. If it is a linear mode, we can control torque effectively. Advantage is, if it is linear mode, torque is depends on only one variable. By regulating the IA, we can control torque. Clear? This is the advantage of DC motor. Basically, DC motors, after armature control method, it will offer first order system, linear mode. What is the problem with induction motor? That's why it got 5 out of 5. With respect to controllability point of view, by regulating simple VA, by controlling only one variable, we can control the torque effectively. That's why, with respect to controllability point of view, it got 5 out of 5. Now come to induction motor. Oh, okay, fine. Now come to induction motor. Take three-phase induction motor, induction machine. Now tell me, what is the nature of torque? What is the order of the torque expression for induction machine? What is the nature? What is the torque profile? Okay, this is fine. Just in between I will ask fundamentals. Up to DC machine, everything is fine. Can I ask one question? Why sine waveform? Sine is a reference for electrical students. You got my point? It is a very simple question. Even if you take power system or electrical circuits, electrical machines also, voltage or currents, generally we are representing by V equal to Vm sine omega t, I equal to Im sine omega t or cos omega t. The nature of the sine and cos is both are same. Only time delay is different, 90-degree time delay. Question is why sine is reference for electrical scholars? First, my request is first try to understand the question. This is very important. You have to understand the question clearly, right? You have to think and you can tell, no issue. My question is, why all electrical signals we are representing in terms of sine, V equal to Vm sine omega. Why sine is reference for electrical engineers? Why we need to apply sine signal to the fan? We are applying sine waveform only. If you want, you can check using CRO. What is the reason? This one, without fundamentals, if I explain advanced methods, 1 hour, 3 days, 6 days workshop, No use. You got my point? This is. This is our reference signal. This signal is God for us. Am I correct or not? All signals, all electrical equipment are excited with sine signal, sine waveform. This is our reference. Am I correct or not? Why sine is reference for electrical students? What is meant by sine? What exactly it will indicate sine? One student, at least one student. Sine, very simple question, fundamental question I am asking. Correct. What is sine? Sine is nothing but circle. Sine is nothing but circle. Why it is circle? What is the beauty of circle shape? Why your wheels are in circle shape? Why your motor shape is, rotor core is in circle shape? Why your generator core is in circle shape? Circle is nothing but minimum losses. Sorry? No. Circle nothing but minimum losses. Why circle I will tell. Please try to understand. See, if you take rotor core, if your rotor core is in circle, what is the advantage? I will take rectangular shape or square waveform. See, there are three types of rotors are there. One is rectangular in shape, another one is square shape, another one is in circle shape. Right? All three, let us assume that are rotating with 1000 RPM. In which case, your shaft will struggle like anything. Burden on the shaft is increases more in case of these two machines. Vibrations are more. Centrifugal forces acting on the rotor surface is more if it is other than the circle shape. It is very simple. You got my point? Right? See, if it is in circle shape, centrifugal forces, air, wind torque, friction torque, everything less. Centrifugal forces acting on rotor surface is less. Then in that case, burden on the shaft is very less. So if burden on the shaft is very less, automatically the lifetime of the bearing we can increase. Bearing cost is very expensive. Practically, please try to understand. If you take any EV application or industrial application, bearing cost is almost 15 to 20% of the motor cost. Motor price is 10,000, bearing cost is almost 2 to 3,000 rupees. Very expensive. Circle is nothing but less mechanical losses, less heating effect, less stress. Understood? So after the break, what is the significance of circle? By using space vector concept, I will try to explain so that you will get clarity. Right? After that, using space vector concept here, why sine is reference for electrical students, I will try to explain in detail. After that, what is the nature of torque generated by the machine, synchronous machine and induction motor, I will try to discuss in detail. I don't know how many students are following or not. Anyway, after break, I will ask questions.